Hello, this is Mrs. Ward, and I'm going to go over the notes for section 10.1, which is lines. This is the beginning of chapter 10, topics in analytic geometry. Just want to point out something. So you will have a formula sheet for this, and the formula sheet's on Blackboard. You'll also be given one in class. This formula sheet is the formula sheet that you can use for everything from 10.1 through 10.4. We'll get a different formula sheet with 10.5. So you're not expected to memorize any of these formulas. All right, so in chapter 10.1, we're going over lines. So we're going to find the inclination of a line. We're going to find the angle between two lines, and then we're going to find the distance between a point and a line. So let's start off with talking about lines. When we talk about an inclination of a line, we're going to talk about a non-horizontal line with a positive angle. So since this angle is positive, we want our angle to be between 0 and pi, because that would just be a straight line if the angle was pi. And we're going to measure it again. It's a trig angle, so we're measuring it from the positive x-axis, and we're going counterclockwise. So the first line I have drawn here is a simple little horizontal line. And I know it says non-horizontal, but so I have this horizontal line. So just to tell you that the inclination of this line, this horizontal, has a slope of 0, which means my angle is going to be 0 degrees or 0 radians. If I have an angle that's vertical, so here's my vertical, my slope is going to be undefined as my rise over my run. And so if I'm looking at this angle, if this is my positive angle and I'm rotating counterclockwise, I'm going to say that theta is equal to 90 degrees, or theta is equal to pi over 2, depending if I was in degrees or radians. If I have an angle that looks like this, if I'm going from the positive x-axis and rotating counterclockwise, I'm going to see that my theta is going to be an angle that's greater than 0 and less than 90 degrees, or theta is between 0 and pi over 2, which means if you're looking at it, you have an acute angle. And last time, I have an angle that kind of slants backwards, so if I have this angle and I rotate this way, I can see that it is more than 90. Theta is going to be more than 90, less than 180. I should put that in degrees as well. In other words, you have an obtuse angle. And we're going to go through how we find these different angles. So to find the inclination of a line, you should remember that it's going to be the tangent. The slope is going to equal the tangent of theta. So if I say that theta is equal to pi over 4, then my slope will be the tangent of pi over 4. And the tangent of pi over 4 is 1, so my slope is 1. So I can either find the slope of the line based on whether I have my angle, or I can find the angle but if I have the slope. So now when I go to find the inclination of the line given by the equation of this, I'm first going to solve for the slope. So in order to solve for the slope, let's say I take 3y is equal to negative square root of 3x minus 3, divide everything by negative 3, and when I do that, I'm going to have y is equal to, negative divided by negative would be positive, so positive square root of 3 over 3x minus 1. I really don't care about this. I care about my slope. My slope is the square root of 3 over 3. Hopefully you recognize it from your unit circle, but if not, you're going to do the inverse tangent of the square root of 3 over 3. And when I do that, I'm going to get, you won't get pi over 6, 30 degrees. You will get 30 degrees. You won't get pi over 6. But I should know that from my unit circle. Then I would get the 30 degrees. All right. Find the inclination of a line given by 5x minus y plus 3. So I'm going to put the y on the other side and leave everything else here. So here I can see that my slope is 5. So to find the inclination of the line, I'm going to do the inverse tangent of 5 is equal to theta. When I first do that on my calculator, I get an answer of 1.3 3/8. That is my radian answer. To change it to degrees, I'm multiplying by 180 over pi, or doing the GD button on my calculator, and I get 78.69 degrees. Now, there's an extra one that I have here that's not on your note sheet. If I'm finding the inclination of the line here, when I solve this, I'm going to have y is equal to negative 2/3 x plus 2. So my slope is a negative 2/3. When I do this in my calculator, when I first do the inverse tangent of a negative 2/3, I'm expecting an answer from my fourth quadrant, because remember, my inverse tangent is only going to give me an answer from the first or the fourth. Since it's negative, it's going to be from the fourth. When I do this, I get theta to equal negative 0.588. That's in radians. When I change it to degrees, I get negative 33.69 degrees. So if I think about this, here's my line, and it could be anywhere, but let's say it's here. And this going down is my 33.69 degrees. But I want it from the positive x-axis going counterclockwise. So to make that adjustment, it's literally halfway around the circle. So I can take that negative 33 and add 180 degrees. And when I do that, I get an answer of 146.31 degrees. That is my correct answer. Remember, to find the inclination of the line, it has to be a positive angle between 0 and 180 degrees. So if I get this negative answer, I must adjust for it to make it a positive angle. Okay, the next formula I'm going to see here, oh, I have that. The next formula I'm going to see is for a non-perpendicular line that has a slope 1 and another slope 2. So you have two different lines here. Then the angle between those two lines is given by that formula right there. So I'm going to take the second slope minus the first slope, and then put it all over 1 plus 2 slopes multiplied. Now, since I'm taking the absolute value, it really doesn't matter if I take m2 minus m1 or m1 minus m2, because the absolute value will take care of it. So what I'm going to do is, when I'm doing this, is I'm finding the slope between these two lines. So let's actually do one. So finding the angle between two lines, I have line 1 and line 2. So the first thing I'm going to do is I'm going to find slope 1. And when I do that, I set y equal to self-bites. So I'm going to say y is equal to negative 2x plus 4. So slope 1 is going to be a negative 2. To find slope 2, I'm going to take negative y is equal to negative x plus 2, divide everything by negative. And so slope 2 is going to be a positive 1. Now I'm going to put it into that formula where I'm going to do set equal to tangent. So tangent of theta is equal to the absolute value, if I'm following slope 1 minus slope 2, all over 1 plus slope, no, it doesn't really matter, slope 1 times slope 2. So when I do this, I'm going to have tangent of theta is equal to, and then this will be 3 over negative 1. So negative 3, well, positive 3. Tangent of theta is equal to the absolute value of negative 3, which I'm just going to make 3. Now I'm going to do the inverse tangent of that. I said inverse tangent, I think it's 3. And when I do that, I get 1.25 is equal to theta. That's my radians. Change it to degrees, and I get 71.57 degrees. And it should make sense to you that if I have the intersection of any two lines, like if I do these two lines, I'm going to find that the inclination between the two is always going to be an acute angle. So let's do the next one. Find the distance between a point and the line. So you're going to have to write the equation of your line in the form of ax plus by plus c is equal to 0. Then what you're going to do is you're going to have your coefficients of your x, your y, and then your constant. and you're going to put them into this formula here. And d stands for distance. So what you're doing is you're taking this point here, you know the equation of this line here, and then you're able to find this distance here. So let's do one. So find the distance between the point and the line. So the line is 4x plus 3y is equal to 0. Technically, I should rethink of it as x plus 3y minus 0 is equal to 0. It doesn't matter if it's plus or minus, but you really should have everything on one side set equal to 0 on the other side. So I just want to make sure that you realize that your C is equal to 0. In this case, my A is 4, my B is 3, and then my point, my x1 and my x2 is going to be, this is going to be my x1 and this is going to be my y1. So that is my point. So to find the distance, I'm going to say that's equal to the absolute value of A, which is 4, times x, which is 0, x1, plus B, which is 3, times the y coordinate, which is 2, plus my constant, which is 0. And I'm taking the absolute value of all that all over the square root of A squared plus B squared. So when I do that, I'm going to have 0, so the numerator will be absolute value of 6 all over the square root of 25. So I will end up with a distance of 6 fifths. So find the distance between the point 3, -2, and the lines -7x plus 3y is equal to 11. So I'm going to rewrite this as -7x plus 3y minus 11 is equal to 0. Remember, they're setting the equation equal to 0. This is my x1, this is my y1. So to find the distance, I'm going to take the absolute value of A times my x coordinate plus B times my y coordinate plus c, so I'm going to write minus 11 all over the square root of -7 squared plus 3 squared. So when I do the numerator, I'm going to get -21 minus 6 minus 11. So that's going to be the absolute value of -38 over the square root of 49 plus 9. So that's going to equal 38 over the square root of 58. 58 is just 2 times 29, so I cannot simplify that, so I am going to rationalize. And my final answer for my distance is going to equal 38 times the square root of 58 all over 58. Whoopsie, I can simplify that, can I not? I can. So my distance is equal to 19 times the square root of 58 over 29. And that is my final distance. And the reason why it's so important that we find the distance between a point and a line is we can use that to find the area of a triangle. And I have a triangle with the vertices 0, 0, 1, 5, and 3, 1. Wants me to find the altitude from B to side AC. So the first thing, I need a visual. So I'm just going to do a really rough sketch. 0, 0 is point A. B is 1, 5, so let's put that there. And then C is 3, 1, so we'll put that there. Just a rough sketch so I can see what I'm doing. Then it asks me to find the altitude from vertex B to side AC. Now I can find any altitude. I'm just following the directions. So I could have found the altitude C to AB or A to BC. Does not matter. So in order to do this, I'm using that distance formula that I just used, which means in order to do that, I need to know the equation of this line. So that's the first thing I'm going to do, is I'm going to find the equation for AC, that line. And in order to do that, I'm first going to find the slope of AC. So to find the slope of AC, I'm going to do the difference of the x's. I'm sorry, the difference of the y's. So 1 minus 0 over 3 minus 0. And I'm going to get a slope of 1/3. Then if my slope is 1/3, I could use this point. Y is equal to mx y is equal to mx plus b, and I'm going to get my y-intercept to 0, which I should have known, but that's how you do it in case you didn't know. So the equation of this line is going to be y is equal to 1/3 x plus 0. I can leave it like that, or I can say, hey, I don't want to work with fractions, and I can multiply everything by 3. And if I do that, I'm going to 3y is equal to x. Rewrite it, setting it equal to 0. I'm going to have negative x plus 3y. Technically, plus 0 is equal to 0. So here's my a, my b, my c. If I left it as 1/3 for my a and negative 1/3 and 1, that I'm still going to get the same answer. Now, this b, that ordered pair, is 1, 5. So this is my x sub 1. This is my y sub 1. So I have a 0.15, so now I'm putting into that distance formula, so I'm going to say distance is equal to the absolute value of A, which I just said was -1, times my x1 coordinate, which is 1, plus B, which is 3, times my y1 coordinate, which is 5, plus c, which is 0, all over the square root of a squared, so -1 squared plus b squared. And when I do that, I'm going to have 15 minus 1, so that's going to be 14, the absolute value of 14, which is 14 over the square root of 10, I believe. And then so that's my distance, so that's my altitude is going to be, what did I just say it was? I said it was 14 over the square root of 10. And yes, I know that I should rationalize it, but it's a work in progress, so I'm going to leave it like that. So to find the area of a triangle, I'm going to take 1/2 the base. Well, the base would be the distance from here to here, so I'm going to do the distance formula for that. So the distance of AC, or the length of AC, is going to be you're making this right triangle, and then this is going to be 3, and this is going to be 1. So that's going to end up being this 10. And technically, I took, why am I having such a hard time thinking? Oh, this is actually 1, and this is actually 2. And I skipped a lot of steps, but what I did is the distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. But you know what? You already did it when you had the slope. Isn't this the difference of the y's and this is the difference of the x's? So you can go back here and just grab your slope. It's the same thing. So look at the square root of 10. So to find the area of this triangle, I'm going to take 1/2 the base, I just said was the square root of 10, times the height, which is 14 over the square root of 10. And if you don't simplify and you don't rationalize, what should happen is these should simplify 90% of the time. And so I'm going to end up with 1/2 times 14, which is 7. So my answer is going to be 7 square units. And that's how I'm going to find the area of the triangle. All right, I hope this helps, and I'll see you next time.